As we finish lesson C8 in algebra, we're working with recursive formulas. Now, a recursive formula is a set of statements that indicate A, the first term, and B, the rule for how you get the next term. And it's always usually related to the previous term. So when we are asked to write recursive, you're going to have two things. The first term, the starting value, term 1, and t of n. This expression shows, as it says here, it shows what you do to the previous term to get the next one. And usually we're not going to write the word previous term that you see down here. We're going to use t to the n minus 1. And if you think of that, if t to the n is the term, the one before it is n minus 1. Now, as you finish off these notes tonight, one of the things we're looking at is this example of a sequence. And a lot of you can say, oh, I see the pattern, 40, 20, 10, 5. I am dividing by 2. Now remember, dividing by 2 is actually the same as multiplying by a half. But as we are looking at this, if you think, oh, I'm dividing by 2, we write our formula for the recursive formula as t to the 1 equals 40. And our nth term is the previous divided by 2. So we could write it t to the 1 equals 40, or our nth term is going to be t to the n minus 1 times 2. Now I mentioned that some people like to think of, instead of dividing by 2, they like to think, oh, we're multiplying by a half. How could you write this differently if you were multiplying each one by a half? Your first term would be the same, t of 1 would equal 40, but then our t of n in this case would be our 1/2 times the previous term. Is this exactly the same as what we have here? Yes, it's just written in a different notation. So both of those would work. As you practice this last one in your notes, it says, to repay a $200 loan, you make a $20 payment each month. At the end of the month, the question is, you receive a statement telling you how much money you still owe. Make a list of your outstanding debts after 6 months. So if we want to think of this, we want to think, what is our first one? So t to the 1. We started with 200. We're paying 20. How much do we still owe? Our outstanding debt after the first month will be $180. Term 2, subtract another 20, we're at 160. Term 3 is going to be 160 minus 20 gives us 140. Term 4 should be at 120. Term 5 should be at 100. And term 6, in this case, our statement would show that we still owe $80. If we want to write a recursive formula, so recursive, we always need to have the two things. Our first term, which is not the 200, that's our 0. The first term is 180. How do we get the next term, t to the n? We take our previous term, so the 180, which this case will be t to the n minus 1, and we are subtracting 20. And this works for all values n when it is greater or equal to 2. Remember, we are only working with, when we look at these, our whole numbers. When we look at a sequence, we can't have a half number in between in a sequence. So you are now asked to write a recursive formula for each one. Again, always have to have two things. T to the 1, t to the n. I'm going to do the first one. I want you to try the second one. Look for the pattern first. Are we multiplying, or are we adding or dividing, subtracting? 7 to 21, most of you thinking probably times 3. Does it hold? 21 times 3 does give us 63. So that pattern looks like it continues. T to the 1, our first term is 7. How do we get the next term? We are taking our t to the n minus 1, and we're multiplying it by 3 for n greater or equal to 2. As you look at this next one, think again, are we multiplying, dividing, adding, subtracting to continue to get the next term? It looks like there's a constant change, so look at that, pause the video, and then you're going to fill this in. As you paused it, you should have noticed that each time you were adding 5. So if we are adding 5 each time, our t to the 1, first term is -2. Our t to the n, which would be how we could check the second term, third term, whatnot, is going to be t to the n minus 1, and then it is going to be plus 5 for all values n greater or equal to 2. The question often comes up is, could I check this? Could I make sure I'm doing this right? And this doesn't make sense to me, so I'm not sure if I did it right. So what if you wanted to choose, this is our first, third, fourth, fifth term. Let's check if t to the n, or in this case t to the 5, does it equal the previous term? Well, our previous term is 13 plus 5. And 13 plus 5 does equal 18, and that is what term t5 is equal to. So you can check it by plugging in that number of the term and then doing the previous plus to check. We'll be looking at your homework in class. We'll probably take a couple of days on this. We'll go back over the notes from the last 2 days, so I hope this made some sense to you. And again, go back and rewind and look at what you need to have for the different formulas, both recursive and explicit.